This is BYU Math 112. In this video we will discuss textbook section 3.5, exercise number 56. Our directions read, find the derivative of the function, simplify where possible. Our function, f of theta equals arcsine of the square root of the sine of theta. As we're going to be taking the derivative, it's helpful to see exactly what we're going to do, so we can rewrite our function as the arcsine of sine of theta to the 1/2 power. So we can clearly see we have an arcsine function, we have a square rooting function, and we have a sine function, all of which we're going to eventually take the derivative of because we're going to use the chain rule. So our f prime at theta, the derivative of the outermost function at the inside function. So the derivative of arcsine is 1 over the square root of 1 minus, and then your interior function, square root sine theta squared, 1 over 1 minus x squared. So there's our square root of sine of theta as our interior function. So derivative arcsine, check. Next is our power rule, because we have a 1/2 power. So chain rule, we multiply these derivatives. So we have 1/2 times the function to the power minus 1. So 1/2 minus 1 is negative 1/2. And then the derivative of the next most interior function is derivative of sine is cosine. And then last but not least, we would take the derivative of theta with respect to theta, which is just a 1. So this is what we have to deal with. We can simplify it. For our first term, we have a square root of sine squared, so we can rewrite that as the square root of 1 minus sine of theta. And then our sine of theta to the negative 1/2 means we're taking the square root of the sine, but in the denominator. So we have 1 over 2 square root sine of theta, and we can't do anything with the cosine, so we leave that the way it is. And then we can simplify this by writing them all as one fraction. So we have the cosine of theta on the top, and then we have 2 times our 2 square roots. It doesn't really matter which order we put them in, as long as we list them both. So that's how we take the derivative of something with 3 embedded functions. Make sure we use our chain rule, simplify as much as possible, and that's number 56.